Lesson 28, solving problems using sine and cosine. All right, we've been talking about sine and cosine quite a bit. So let's go ahead and look at this. The bus drops you off at the corner of H Street and First Street, approximately 300 feet from school. You plan to walk to your friend Janet's house after school to work on a project. Approximately how many feet will you have to walk from school to Janet's house? Round your answer to the nearest foot. Hint, use the ratios you developed in lesson 25. All right, so these are the ratios. These are their sine and cosine type ratios that we're dealing with. All right, so let's talk about what it wants to know. It says that the bus is going to drop us off at the corner of H Street and First Street. So the bus is going to drop us off here. Approximately 300 feet from school. All right. So you plan to walk to your friend Janet's house after school to work on a project. They want to know how many feet will you have to walk from school to Janet's house. Round your answer to the nearest foot. All right, so we're going to let X represent the distance from school to Janet's house. All right. We always want to identify our variable. So we're going to let X represent the distance from school to Janet's house. Okay, now I can't use the Pythagorean theorem because I don't have two measurements on my side. I only know that I'm looking at the distance of 300 feet from school to where the school bus dropped me off. So if I had the measure of another side, I could use Pythagorean theorem and I would be able to solve this, figuring out how far this is, or figuring out my hypotenuse. Okay? So I have to use the ratios that we have created in the last several lessons. All right, so let's think about what we know. All right, the sine of a 41-degree angle. All right, I have this angle, 41. All right, we know that sine is opposite over hypotenuse. All right, and I don't have lesson 25. I was going to say that would be a nice lesson to have out. We did create some ratios in lesson 25. It was the one where we actually measured our angles. Hang on, let me see if I can find that lesson so we can look at it. Found it. Okay. So we created these ratios, if you remember. So it may be something you want to go back and get out if you have not turned it in just yet. If you have, then here's this. You might want to take a screenshot of it or whatever. But we looked at a 41-degree angle here. And if you remember, we hadn't quite identified sine, cosine, and tangent just yet. All right? At this point in time, we were still using opposite over hypotenuse and adjacent over hypotenuse. All right? But we have since identified that sine of a 45-degree or a 41-degree angle is sine is opposite over hypotenuse. Now, we figured out that opposite over hypotenuse was 5.3 over 8. All right? So, ratio here, and we can use the sine of that 45 or 41 degree angle. So the opposite here is 300 over hypotenuse is x, because that's what we are looking at, is equal to 5.3 over 8. Alright, so we're going to multiply. So I get 5.3 times x is equal to 8 times 3 is 24, and I add 2 zeros. And I'm going to divide by 5.3 to figure out that x is equal to, alright, so 2400 divided by 5.3. Now it says round to the nearest foot. Alright, so I want to round this to the nearest whole number. Alright, so I'm going to round this to, since this is an 8, I'm going to bump it up. So about 453 feet. I'm going to write this down here. And then we're going to say that we would walk, the distance that I'd have to walk is approximately 453 feet. Alright. Not too bad. Alright, let's look at question number 2. Part B. In real life, it is unlikely that you would calculate the distance between school and Janet's house in this manner. Describe a similar situation in which you might actually want to determine the distance between 2 points using a trigonometric ratio. Guys, it might be something like calculating the distance to determine if a vehicle has enough fuel, enough gas to make it on a trip. Alright? So we might be trying to figure out if we have enough gas to go on a trip. Alright? So maybe that's what I'm trying to figure out. It might be something, maybe I want to take a walk. Alright? And your friend's on crutches. And so you want to, you need to calculate, you want to see if it's going to be too much of a walk. Something like that. It's not, we can use these differently. Use a calculator to find the sine and cosine of an angle. Give your answer rounded to the 10,000th place. Alright. So, how do I figure this out? Well, we've already talked about sine of a 0, a 30. Let's see, I was trying to think of what I would talk about. A 0, 30, and a 90 degree. A 0, 30, 60, and 90. Alright, we talked about those. So how am I going to figure out the rest of this? Alright, we aren't going to spend a whole lot of time going through and me working these out on a calculator for you. So if you want to pause your video here, I'm just going to kind of fill in the chart. And you can do this as you go. We said the sine in the last lesson, the sine of a 0 degree angle was 0, and the cosine of the 0 degree angle was 1. And if you remember, the 90 degree was just the opposite. Alright? Alright? So the sine of a 10 degree angle like I said, once it in the nearest 10,000ths place, let me just go ahead and we're gonna fill these in. And I don't know why they don't give us more of a box to put 5 digits and a decimal, but they don't. So we're just gonna squeeze them in the best that we can. Alright. So pause your video, go ahead and fill these in. What do you notice about the numbers in the row sine of an angle compared to the numbers in the row of the cosine of an angle? Well, once again, if you look at them, the numbers are the same, just in reverse order. Provide an explanation for what you notice in exercise 2. Well, what did we figure out? Guys, these are complements of each other. 80 and 10 are complements of each other. 20 and 70 are complements of each other. What did we say about complements? So, because the sine and cosine of complementary, because the angles are complements, then we know that the sine and the cosine of complementary angles are equal. Alright. Find the missing value of A and B. Alright, now we know how to calculate sine and cosine of a given angle. Alright. We can use the decimal value of the ratio to determine the unknown side length of a triangle. So what can we do to find the length of side A? Well, we can, if I want to find the length of side A, then I can look at the sine of the 40 degree or the cosine of the 50 degree angle. Alright, well let's begin by using the sine of the 40. Alright, so the sine of a 40 is equal to A over 26, because sine is opposite over hypotenuse. To calculate the length of A, we must determine the value of 26 sine of 40, because A is equal to 26 sine of 40. So we will round our answer to 2 decimal places. Alright, so this is where your graphing calculators will come in handy. Alright, so let's figure out the sine of a 40 degree angle. Alright, so here's what I did. Alright, here I've got trig, and I hit sine, and then it tells me to find that. Now, I want to multiply that times 26. Alright, which gives me 16.71. Alright? So, and let me talk to you about how I figured that out. So if I want to find A here, I can multiply both sides by 26. Okay? I got a little ahead of myself. So then that gives me that A is equal to 26 times the sine of a 40-degree angle. Alright, so we find out that A is approximately 16.71. Alright? Alright? Guys, you will need your calculators. And that's where, that's what I did here, is I just used my trig calculator and did the sine of a 10-degree angle and rounded it, okay? It wasn't some magical way that I could figure things out. I used my calculator, all right? That scientific calculator. If you have an iPhone, flip your iPhone sideways, it gives you a scientific calculator, all right? All right. So now I figured out A. Now we can use the sine, now we can use the cosine of 50 to figure out, well, no, we said we could use the cosine of 50 in order to get A. We don't need to do that. We've already done that. All right? We're going to get the same thing if we use the cosine of 50. And we won't spend time showing you that. Alright, so now we need to calculate this length of side B. Alright, side B can be used, well let's look, B is the opposite, so I can use the sine of 50, or it's the adjacent of A, so I can use the sine of 50, or I can use the cosine of 40. Alright, it doesn't matter which one you want to do. So, let's go ahead and use the sine of 50. Alright, so the sine of 50 is opposite B over hypotenuse, which is 26. Alright, remember I can multiply everything by 26. And that gives me 26 times the sine of 50 is equal to B. Alright, so I'm going to use my calculator. And I'm going to, let me clear this off so I can see. I'm going to use the sine of a 50-degree angle, and I'm going to multiply that times 26, which gives me approximately 19.92. Could we have used another method? Yes, once we know two sides, we can use the Pythagorean theorem. Your choice, however you want to do this. But I'm trying to get you into using those sine, cosine to figure out things. All right. Exercise number 5. A shipmate set a boat to sail exactly 27 degrees northeast from the dock. After traveling 120 miles, the shipmate realized that he had misunderstood the instruction from the captain. He was supposed to set sail going directly east. Alright, so how many miles will the shipmate have to travel directly south before he is directly east of the dock? So he went this way, but he was supposed to be going this way. So we can create a right triangle here. Alright? So they want to know how many miles is he going to have to go south to get where he should have already been. Alright. So we're going to let S represent the distance that they have to travel south. So we've got S is representing the distance that we travel south. Alright. So looking at this, I have a 27-degree angle. My distance that he's already traveled is the hypotenuse. I want to find the opposite. So opposite over hypotenuse is the sine. So I'm going to use the sine of 27, and that would be S over 120. Alright, now I can multiply everything times 120, and I'm going to get 120 times the sine of 27 is equal to S. Alright, so now let's hit my trig, hit my sine, the sine of a 27-degree angle, and then I'm going to multiply that times 120, and I get S is approximately 54.4789. So S is approximately 54 miles south. Alright. How many extra miles does the shipmate travel by going the wrong direction compared to going directly east? Round your answer to the nearest mile. Alright, well, so think about this for just a second. We can use the Pythagorean theorem. We may use the cosine of functions. I'm going to stick with using cosine because I want you all to get used to that. It is completely up to you what you decide to do. Alright, so we figured out that this was approximately 54. Alright. So we're going to use the cosine of a 27-degree angle. Cosine is adjacent. I don't know what that is, so we'll just let it be E because he was supposed to go east over 120. Alright, I can multiply everything times 120. And I like doing this because I can let the calculator do a lot of my work for me, where with Pythagorean theorem, I have to do the squares and then the square roots. Alright, so I get 120 times the cosine of 27 is equal to E. Alright, let's go over here and we're going to do, this time we're going to hit the cosine of 27-degree angle, and then we're going to multiply that times 120, and I get approximately 106.921. Alright, so we're going to say, let's see, E is 106.921. So E is approximately 107 miles. Alright, so the total distance traveled by the boat is, he traveled 120 plus 54. Alright, so we got the 120 here. Sorry, the 120 here, and then the 54 here. So, total distance traveled was 120 plus 54, which is 174. And he really only had to travel 107 miles. So 174 minus 107 is 67 extra miles. So he traveled 67 extra miles. Alright? Alright, exercise 2. Alright. Joanna borrowed some tools from a friend so that she could precisely but not exactly measure the corner space in her backyard to plant some vegetables. She wants to build a fence to prevent her dog from digging up the seeds that she plants. Joanna returned the tools to her friend before making the most important measurement, the one that would give the length of the fence. Joanna decided that she can use the Pythagorean theorem to find the length of the fence she'd need. Is the Pythagorean theorem applicable in this situation? Explain. Can she use the Pythagorean theorem here? What do I have to know? What do I have to have in order to use the Pythagorean theorem? I have to have a right triangle. Do I have a right triangle here? I do not. So can I use Pythagorean theorem? No. The corner angle is not a right angle. The corner angle measures 95 degrees. Alright, so since we do not have the Pythagorean, or since we do not have a right angle, I can not use the Pythagorean theorem. Now, okay, I say I can't. It would not give me an exact. I can estimate using the Pythagorean theorem because this is close to a 90-degree angle. But I'm not going to be able to get an exact measure. Okay? So I can't do that. So what can we do to help Joanna figure out the length of the fence she needs? Alright? Let's say that we dropped an altitude. Alright, if I dropped an altitude, then would I be able to figure this out? I would, because then I could use my 35-degree angle and my 50-degree angle, because since this is an altitude, it forms right angles, so then I have right triangles. So I could do this. The measurement of the triangle shown below are rounded to the nearest hundredth. Calculate the missing side length to the nearest hundredth. Alright, so, guys, I'm going to drop an altitude. Alright? So I'm going to drop an altitude from this angle here. I don't have right angles, so I'm going to drop an altitude. Alright, so now let's think about this. So I've got, we'll label these X and Y. So the missing length would be X plus Y. Alright, so I need to find X. Alright? So I've got X is my adjacent over hypotenuse. So I'm going to do the cosine of a 39-degree angle. Alright, which would be X over 4.04 multiply everything times 4.04. Alright, so then let's look at my calculator here. Whoops, sorry. I'm going to clear this off just a little bit. So I got the cosine of a 39-degree angle, and I'm going to multiply that times 4.04, and I get approximately 3.13967. Alright, and I'm going to leave that like that, 3.13967. Alright, and then I'm going to look at my Y, which is my adjacent over hypotenuse. So I'm going to find the cosine of a 42-degree angle, which is Y over 300 or 3.85. Multiply everything times 3.85. Alright, so then I get the cosine of a 42-degree angle. Alright, and then I'm going to multiply that times 3.85. So I get that Y is approximately 2.86111. Now, in order to figure that out, I would add these, 3.13967 was 2.86111. Alright, which gives me 3.13967 plus 2.86111, which gives me 6.00078. So we're going to say it is approximately 6. Alright, hopefully not too difficult. Hopefully you're catching on to using sine and cosine. You know, it's not a hard concept, but it does take some time. Alright guys, have a great rest of the week.